Recording is rolling. It's Friday, January 13th. So, stuff lined up today. I don't know if you guys know Sydney Ashford. She's got a survey going around for AP Capstone. So I did post a link to Google Classroom. Yeah, guys, could do that. I haven't taken it myself. Supposedly it's like 5 or 10 minutes. So could help her out. Help out one of your fellow moms there. All right, so yesterday one of these problems stumped me. We're gonna revisit that. Actually, I think Scarlett got it right before the end of class too. So I don't know. Anybody else figure that one out? Household number 19 with the bananas like bouncing up and down. All right, so we'll do that one here pretty soon. I got a ripple paint doing for you guys. I want to do something a little bit different with the AP Classroom. So this is going to be due on Tuesday. I'm going to do the first few problems with you guys because there's like 22 questions and wouldn't have enough time to do all of them on Tuesday anyway, but we'll do the first few just a little bit slower than normal today. Okay. All right, so get you guys a head start on that. Right, we'll finish that on Tuesday. I have enough RQ lined up for you guys next week, and let's do an in-class quiz on Thursday next week. Right, and then I'll pick up the college problems, college physics problems then too. Okay. What do you guys feel like? Do you guys want to do open notes, closed notes? What would help? What would be best for you? Open notes is better. All right. Well, up and towards that, we'll probably do that then. Okay. All right. So let's set this college physics problem. All right. So this one had me stumped yesterday. All right. So we got these bananas. These are the values they gave us. They told us the spring constant. How the spring is. They told us, right, we're going to pull this thing down 20 centimeters to 0.2 meters. We're going to let it go. They told us maximum velocity. And the question is, what's the weight of the bananas? But I think it's easier to solve for mass first and then just multiply by gravity until we get the weight. So let's solve for this first. Okay. And what's probably figured out and pointed out to me right before the bell rang yesterday was that, oh yeah, actually you want to start right here with this oscillatory motion. Okay. Now, actually most textbooks have start with like a cosine curve is the x versus t. I think I'm gonna go change this poster for future classes. There's cosine, negative sine, negative cosine. Okay. But that doesn't really matter because you really describe either with like a sine or a cosine. And that's not going to change the amplitude of this thing. So the fact that the speed through the equilibrium point is this many meters per second, 0.4 meters per second, that is the maximum speed. So really we're looking at like the amplitude of the velocity versus time curve, right? And the amplitude of velocity versus time is a times omega, where omega is not angular velocity from last December, but it's angular frequency, right? So a little bit different context. I know there's only so many characters to go around between the Latin and Greek alphabet, so some of these get recycled, right? And you guys remember angular frequency is 2 pi times the regular frequency, 2 pi f. Okay, and it has to do with like fitting in these sine cosine graphs. Okay, right, so let's start with that.
Good morning, Mom. Happy Friday. We are coming to you live from Mrs. Davis's room where she's our hawk of the week. Mrs. Davis was nominated by many students and teachers over the past few weeks. Ms. Becerra said Ms. Davis serves as a support for so many students on this campus. A few weeks ago, there were 2 students who named Ms. Davis, and without hesitation, she responded and did whatever she could to help them feel supported. Mrs. Davis provides a safe place for students in and out of their classrooms to know they can reach out for support at any time. According to Mrs. Ivy, Mrs. Davis is always willing to help staff and students in academic and extracurricular success. Thank you, Ms. Davis, for always doing above and beyond for our school and our community. And now we have our student hawk of the week, 11th grade, Manny Mira, nominated by Ms. Jones. Manny's hardworking and always willing to do anything asked of him. He recently was out of the country and is working hard to get caught up. His personality lights up the room and he's one of the most genuine kids I've ever met. We also have 11th grader Nick Monahan, nominated by Ms. Brush. Nick worked so hard this semester. At the beginning of the year, he had a little bit of trouble catching up with his work, but rather than getting discouraged or give up, Nick redoubled his efforts in my class. Now he is excelling. His positive attitude and perseverance has really paid off, and he has one of the highest grades in the class. Not only that, but Nick's constant study habits have encouraged other kids to try harder. And 12th grader Kevin Rose, nominated by Mr. Moreland. Kevin is kind to be kind. I consistently see him going out of his way for his classmates, even down to the simplest acts like getting materials for peers around him. He's a hard worker and a great example of a leader. And now our Friday announcements. Congratulations to winter sports on all of their wins this week. Good luck to girls basketball who travel with Gibson this weekend in the MLK tournament. Reminder, Vieira Stock talent applications have been extended until Tuesday the 19th. Please drop off your applications in the drama classroom 6125. High school musical auditions are next Tuesday and Wednesday, 17th and 18th. You must fill out an audition application in order to audition. See Ms. Barnhill in the drama classroom 6125 for more information. And that's it for announcements here. Have a great day and go talk.
All right, so got kick started here a little bit. So this really turned out to be a complex problem in the sense that there's just a lot of little bits they have to put all together. Okay. So took advantage of this. We know what the like physical amplitude is in terms of meters, right? We're pulling this thing, right? And we know the maximum speed at the center. So you put those ideas together. Now whether you use sine or cosine or negative sine, it doesn't really matter because the maximum of one of these oscillating curves is going to be 1, right? Sine or cosine of anything, it's going to max out at 1. So the fact this is the maximum through the center, right? We're looking at like the peak of this curve, right? Okay. And the peak of this curve is going to correspond to like the equilibrium of the position, right? It's moving the fastest through the equilibrium point. That's what we're saying, right? This corresponds to this. Okay. Right. So all this stuff, the fact that it's maximum through the center, we're just gonna let be equal to 1, and that would correspond to V max, which they told us was this number here. Okay. So the physical amplitude in terms of meters is this right here. Here's your angular frequency, and then you can solve for frequency because you know everything except for that ends up being this many hertz. Okay. You guys remember time period and frequency are reciprocals of each other, right? Like if you hear like tick 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 tick, that's about 4 beats per second, 4 hertz, and the time period between beats would be a fourth of a second. You guys know that. Okay. Okay, so the time period of oscillation is 3.14 seconds. Actually, that's rounded a little bit. It ends up being pi, right? So pi seconds. Okay. So it takes 3.14 seconds to bounce up and down. So, okay, so 1 full cycle, right? Down and up again, or up and down again. All right, so so that's about half the problem there. Okay. Now, the question was, what's the weight of the bananas? But we're going to solve for mass first, right? Mass of the bananas. You guys should definitely be able to get it from here. Here, go ahead. Everybody get the mass of the bananas. The fact that you know the time period and you know the spring constant. Okay, give you guys a little bit of time here to solve for the mass. Or sorry, yeah, solve for the mass of the bananas. All right, you got it. All right, okay, so we're gonna. All right, you know what you're doing? Go ahead. If you're totally stuck, then right. See if you know the time period, you know how stiff the spring is. You guys are thinking this right here, right? That means you know these two things. You're trying to get this right here, right? Because whenever you see oscillating motion with a spring, think this formula. I mean, it's going to come in some play at some time, right? It's 3.14 seconds is the time period. Okay. Anybody got the answer yet? Solve this in terms of variables. Try to unvary that down, right? Okay. So hopefully everybody's at least this far. Well, pi squared cancels. You guys get 4 kilograms exactly for the mass. 4 kilograms from mass. Okay. Guys, if the mass is 4 kilograms, and we're probably on Earth, because I know bananas are in the universe, then what's the weight? Yeah, 40 newtons. Or say like 39.2 or something like that. Yeah, 40 newtons. Okay. So they are weight of bananas. All right. That was a pretty fun one. All right, so you guys okay with that one? Right. It was a pretty complex problem. A lot of little parts got put together for that. Fun adventure. All right. Let's play around with this ripple tank a little bit. This pretty fun demo. Gotta get to see some live ripples going on. Right here. Right. And they put some water and all right. So you can see this right here. I'm gonna take this arm, put it right here, and this is gonna be an oscillator. So yeah, got lights on for this guy. Ooh, all right. So yeah, so you guys see some ripples, right? All right, so you can see like the crest of the waves. Ripples propagating out. There's a couple of knobs here, so I can change the frequency. Can you guys hear the buzzing? You guys hear like the tone? I'm like lowering the tone. Okay, let me go raise the tone. You guys hear the pitch going up? That's like increasing the frequency, right? Hey, if you increase the frequency, what happens to the wavelength? It gets shorter, right? Right? There's an inverse relationship between the frequency and the wavelength. Okay. Does the speed of the waves change? No, the speed is just whatever it is through this particular medium. In this case, water. Right? The speed of ripples is whatever it is through water. Okay. Also throw some stuff in here. Let's do a couple of these a little bit. Get some interference patterns to do this right. Oh, here, that's what I want to do too. Let's do the double arm. Bam. Ooh, look at that interference pattern. Right. How about let's go for this straight wave one here. All right. Let's want to play around with that a little bit, guys. Okay. But got a short day, so let's move on and try some else here. All right, guys, ready for lights? For lights, lights. All right, let's switch over to that AP classroom. All right, we'll get you guys started on that anyway. Do this.